So, again, this is for Chapter 3, Section 4, which is the last section in Chapter 3. Again, here's your homework assignment. If you don't have it yet, please get it copied. There we go. Okay, I know you guys don't know a lot about recording devices and stuff. I've had kids ask me if this is a camera.
Is that a camera?
No. It's my microphone. Yeah, I couldn't find a good place to put it. When I first got it, I put it behind the board. And then it was echoey because my voice was actually bouncing off the board and the wall. And then I tried to put it up here and it kept falling. So I tried to put it here and it couldn't pick me up. So I just put it here and I've got it held in with magnets on the side of the board there. So that's what that is. So I don't use it very often. You guys know I normally use the Bluetooth, but my Bluetooth died. So I got to make do with this. Everybody all right? So up first is problem number 3. What they're asking you to do is determine if a given ordered triple is in fact a solution to the system. So what does it mean to be a solution to the system? What do you mean by it fits them? Those are really non-descriptive. Be precise. Huh? What's the it? Kind of. The ordered pair will create a true solution out of each equation. Which I know is what you meant, but I was waiting and being mean, waiting for the exact precise language. So for number 3, the first thing I need is the ordered triple, please. 1, 4, negative 3. All right, now I need the first equation in the system.
2x minus y plus 2 equals negative 5.
Plus 2z, right?
Plus z, no, it's 2.
Plus z equals negative 5. 2x minus y plus z equals negative 5. Everybody all right with that?
Yep.
Second equation in the system is?
5x plus 2y minus 2z equals 19. Yes, I got that one.
Yay.
Good job.
Alright. Third one is?
X minus 3y plus z equals
Negative what?
negative 5.
Negative 5. Okay. What I'm going to do is I'm going to substitute in my x, my y, and my z value, right, into the equation. And I want to determine if I'm going to get something that's true or something that's false. Alright? So what's my x coordinate up here? And what's my y coordinate? And what's my z coordinate? Okay, so all I do is substitute in what I know. And I want to know if this is true or false. So what's 2 times 1?
Oh, that's what we
2, negative, with the times 4 is just negative 4. Plus a negative 3 is just a minus 3. And I want to know. So what's 2 minus 4? Negative 2. Negative 2 minus 3? Negative 5. Is negative 5 equal to negative 5? Okay, so it works for that one. So am I done? No. Which other parts of the system do I have to do this kind of check for? All of them. So, move on to equation number 2. Plug in your values that you know. And again, I want to figure out if this is a true statement. So I get 5 plus 8 plus 6 equals 19. What's 5 plus 8 plus 6? Is 19 equal to 19? All right, so far I'm doing pretty good, right? I'm a solution for the first 2 parts of the system, so now I just have to check the third part. Substitute in. So what's 1 minus 12? What's negative 11? Take away 3. Is negative 14 equal to negative 5?
No.
Okay, so I put a slash saying that it is not a solution to that part. So overall, is this going to be a solution to the system?
No.
But it worked for 2 of them.
No.
Okay, it has to work for all. So I put for an answer, I put no. The ordered triple is not a solution. Everybody okay with number 3? Any questions? All right, number 10. I need the system, please. All 3 parts. Nice and easy so I can get them.
2x minus y plus
Minus y what? 2x minus y what?
Plus 2z equals -7.
Okay, next.
Negative x plus 2y minus 4z equals 5.
Equals positive 5.
Yes.
Alright, and then the last one.
X plus 4y minus 6z equals -1. Am I going too fast?
Nope.
Good job.
Woo. So, you're going to walk me through this. How do I solve a 3x3 system? What's the first thing I do? Okay, so I make two 2x3 systems, right? I use the top and the middle equation and then the middle and the bottom equation. So let me get that written over. Pretty much. So there's my first 2x3 system. And then my the second 2x3 system. Okay. So now, anybody remember what is it that I do next? Have to eliminate what? A variable, right? Doesn't matter which variable I isolate or I remove. No. The only rule is that if I eliminate a variable from the first system here, I have to eliminate the same variable from the second system. Everybody okay? So if I decide to get rid of x up top, I have to get rid of x on the bottom. If I get rid of y on top, I have to get rid of y on the bottom. Everybody good? All right, so the first thing that we need to do is look at this first system here. Which variable do you want me to eliminate? X, y, or z? X. Okay. What's the coefficient on x here? 2. And here? -1. What's the least common multiple between 2 and 1? 2. So I'm going to multiply by 1 outside here and 2 outside here. Everybody okay? Yes? No? Maybe?
Yeah.
All right. So what's 1 times 2? Positive or negative?
Positive.
Positive. What's 2 times -1?
-1.
-2, right? Is that what I want? Do I want one positive, one negative with the same number? Yeah. So that means that my signs are set up just fine. Okay. If you don't want to do that check, what you need to do is after you multiply before you add. So multiply so before I add, some of you get into the habit of just looking up here and going, oh, well, we just cancel this. Well, you have to check and make sure that it actually cancels. All right, so what's 2x take away 2x? 0. So that is what cancels. So you have to make sure that the variable that you wanted to eliminate actually can be eliminated. Okay, sometimes I'll see 2x and 2x. Well, what's 2x plus 2x? 4x, but you guys cross it out. Okay, because you get into the habit of it. Only cross it out if it actually works. Okay? What's -y plus 4y?
3y.
And what's 2z take away 8z?
-4. Wait, -6.
-6, there you go. -6z, and what's -7 plus 10? +3, right? Because 10 is bigger than 7. So we keep the sign on the bigger number. Everybody okay with what I did so far? Okay, now I just repeat it. But what's important here is I started off with 3 variables, right? When I ended, how many variables do I have in this statement now?
2.
Just 2. So I've taken one 2x3 system and knocked it down into a 1x2 system. I'm going to take this 2x3 system, knock it down into a 1x2 system. And then I'm going to put it back together into a 2x2, which you know how to solve. Yep. Actually, I'm going to write it up here so that way I can copy and paste it later, but you do not need to do this part. You can leave it right where it's in. Okay? So, we repeat. So which variable did I eliminate in this top equation? So which variable am I going to eliminate in this equation? X. Okay, so take a look. What do you notice about my x's? They're already eliminating themselves. They have the exact same coefficient and opposite sign. So do I really need to do any multiplication here? No, I'm just going to add down. So what's -x plus x? 0. What's 2y plus 4y?
6y.
What's -4z take away 6z? -10z. And what's 5 plus a -1? Okay, so again, I have one equation with two variables, so I'm going to put it up here with my other equation. And now I have a 2 by 2 system right here that I'm going to use. Everybody good with that? Yeah? No, maybe? Anybody need this page, or can I go on to a new page? Everybody give us 10 so far. Okay? So, now, ignoring that other page for the moment, if I gave you this system and I said, hey, I want you to solve this system by elimination. Which variable do you want to eliminate? Y or Z? Y, okay? Y works. What's the least common multiple between 3 and 6? So what do I multiply the top equation by? -2 about an equation by 1, right? -2 times 3 is -6. 1 times 6 is +6. Good. Distribute. -6y plus 12z equals -6. And 6y minus 10z equals 4. So now what do I do with these? Right, so we're just going to add down. So what's -6y plus 6y? What's 12z take away 10z?
12z take away 10z, that would be 2z.
2z.
Everyone's paying attention.
What's -6 plus 4?
-2.
-2. So how do I get z by itself? So what is z equal to? -1. Okay, so now how many variables can I solve for at any time? 1. So if I have a z, can I go all the way back to the original? No, I have to go back to where I only have 2 variables, right? So do I have an equation that has 2 variables, one of which is a z? Yeah, I have these 2 equations right here that I started on this page with, right? So which one do you want me to use, top or bottom? Top. So I'm going to plug in what I know. Multiply in order to simplify. -6 times -1 is +6. How do I get y by itself? So I get 3y equals -3. And then how do I get y by itself?
Divide by 3.
So what's y equal to?
-1.
Okay, so far I have y equals -1, z equals -1. Now, how do I find x?
Go back to the original equations.
Okay, doesn't matter which of the 3 originals I use?
No, it does not.
Okay. So do you want me to use top, middle, or bottom here? Top, okay. I don't know x. I know y is -1. I know z is -1. And I'm going to solve this for x. So simplify. 2x plus 1 minus 2 equals -7. That's 2x minus 1 equals -7. Add 1 to both sides. 2x equals 6. So what's x equal to? 3. Again, I have to write out my solution. So solution is the ordered triple of 3, -1, -1. And we're done. So for 27, right? We're going to set it up the exact same way. So seeing how we went through that problem, and most of you seem like you're pretty spot on, what's going to happen is once I get the system built, I'm going to just start working. Okay? See if you all can keep up and see if I make any mistakes. Okay? No, but it usually happens. So if I don't say it, you guys are like, "Oh, come on, Pipsley. You're a teacher. You're not supposed to be human," and that's a problem. So I gotta clarify. How dare you make a mistake? What's wrong with you? Didn't you go to school? So what is my system, please, and thank you for 27.
6x plus y minus z equals -2. And then x plus 6y plus 3z equals 23. Then -x plus y plus 2z equals 5.
Okay. Same basic setup here, right? Let me get my lines all ready to go. And again, we split off, right? First middle, or sorry, top middle, and then middle bottom. All right. Which variable do you want me to isolate? Or sorry, which variable do you want me to eliminate? X, Y, or Z? X. Okay. So this is going to be a -1 and a 6. -6x minus y plus z equals 2. 6x plus 36y plus 18z equals 138. Add, that's gone. 35y plus 19z equals 140. So there's 1 done. If I removed x from there, I'll remove x from here. And again, do I have to really multiply here? If I'm trying to remove x? No, they're already same coefficient, opposite signs. So I'm just going to add, so that's gone. I get 7y plus 5z equals 28. Okay, we all right? Yes, no, maybe? All right, let it simmer. If a question pops up, let me know. So from here, right, which variable do you want me to remove? Y or z? Y will be easier, so I'll do y. Multiply the top by 1, the bottom by a -5. So that's going to get us a 35y plus 19z equals 140. Let's try that again. Equals 140. And then distribute on the bottom, and you're going to get -35y minus 25z equals -140. Add. What's 35y? Take away 35y. What's 19y? Take away 25y. What's 19y? Take away 25y. Or sorry, 19z take away 25z is -6z. And what's 140? Take away 140. Okay, the problem that I saw in your homework is several of you would look here and go, oh, it's no solution. Do I still have a variable?
Yes.
That means that it's one solution. So you have to keep working and isolate the variable. So how do I get z by itself?
Z equals 0.
Divide by -6 and get z equals 0. 0 is a perfectly acceptable value to have as a graph, right? We can graph 0 on the x, y, or z axis, correct?
Yeah.
So you can have variable equal to 0 all day. That's no big deal. Okay, so you have to be really careful when you're working through these as to when it's no solution in infinitely many versus one solution where you have to actually keep working to find it. Okay? So I'm going to plug in my z value. 7y plus 5 times 0 equals 28, which means that 7y equals 28, so y equals 4. Everybody good with that? So plug in your y and your z into one of the originals. 6x plus y is 4, z is 0, equals -2. Gets you 6x plus 4 equals -2. 6x equals -6. X equals -1. And then last step, write out your solution. What's the x coordinate to our solution? -1. Y coordinate is, and z coordinate. There you go. For some people, not for most. A lot of people make mistakes because if you miss the negative sign right here, guess what? You're going to do a full page of work and all of it's going to be wrong. It's going to be right, but this answer is going to be all wrong. Okay? The problem with 3x3 systems and 2x2 systems isn't that the process is hard. It's lengthy. It's not hard. But you have to be extremely, extremely precise. Okay? You miss a negative, you drop a negative, you accidentally write 1 times 1 equals, sorry, you accidentally write 1 plus 1 equals 1. You're going to do all of the work, and all of the work might be right, but you guarantee you get the wrong answers because you mismultiplied a negative sign. Okay, so you have to be very, very careful working through this. Everybody okay? Yes, no? Because I know you guys get the big overall process quickly, but you have to be able to follow through at a very high level of accuracy. And that's why this stuff gets kind of annoying. Because you might do all this work and it'll look great, but it's fine. And it's because you wrote -7 plus 5 equals +2 instead of -2. Okay, everybody all right with that? So just be careful, move slow, move direct, and be accurate. All right, use your calculators as a guide if you need to. Double check your work. Everybody good with that? Yeah? All right, anything else y'all need to see done?